Now we will study Kirchhoff's second rule. Kirchhoff's second rule is also called Kirchhoff loop rule or voltage rule. Kirchhoff's second rule is applicable to a closed path or closed loop of a electrical network. The closed path may be this, or this may be this, or this may be this. According to Kirchhoff's second rule, around any closed loop of a network or around any closed loop of a electrical circuit, the algebraic sum of changes in potentials must be 0. Summation dV is equal to 0. This means algebraic sum of changes in potentials must be 0 around any closed loop of a circuit. Change in potential is final potential minus initial potential, or it may be stated in another form. In a closed electrical loop or mesh, the algebraic sum of EMFs is equal to algebraic sum of products of various resistances and respective currents flowing through them. Summation E is the algebraic sum of EMFs in a closed loop, and summation IR is the algebraic sum of product of various resistances and respective currents flowing through them. Now, the following sign conventions are followed in Kirchhoff's second rule. Select any point on a closed electrical loop and traverse the loop in any direction, clockwise or anti-clockwise. If on traversing a loop, if negative terminal of the cell is encountered first, then its EMF is taken as positive, and if on traversing a loop positive terminal of cell is encountered first, then its EMF will be taken as negative. Second sign convention is, if the direction of current through a resistance is in the same direction along which loop is traversed. If the direction of current through a resistance is in the same direction along which loop is traversed, then product of current and resistance is taken as positive, and vice versa. Now we will understand the Kirchhoff second rule, application of Kirchhoff second rule with the help of example. This figure shows an electrical network. The current distributions, they are according to Kirchhoff first rule. Now applying Kirchhoff second rule to the closed path A, B, C, D, E, F, A. A, B, C, D, E, F, A. When we move along A, B, C, D, F, A, positive terminal of cell is encountered first, therefore its EMF E2 will be negative. And then second, we encounter this second cell, its negative terminal is encountered first, therefore EMF will be positive. Therefore minus E2 plus E1 is equal to. Now when we move along this, then the direction of current in the resistance is in a direction opposite to the direction along which path is traversed. Therefore product of I2 R2 will be negative, minus I2 R2 plus. Second, here the second resistance is R1. The current is in the same direction along which path is traversed. Therefore product of current and resistance will be taken as positive. Therefore plus I1 R1. This is summation E and this is summation IR. Now for the closed loop A, B, E, F, A, when we move along A, B, E, F, A, negative terminal of cell is encountered first, therefore its EMF will be positive. E1 is equal to I3 R3 and plus I1 R1, because current through the resistance is in same direction along which loop is traversed. Now for the loop BEDCB, loop is traversed along BEDCB, as the negative terminal is encountered first, therefore it is E2 is equal to I3R3 plus I2R2. Kirchhoff's second rule implies that net change in energy of the charge after it traverses a closed loop, this must be 0. This is because electrostatic forces are conservative forces. Therefore Kirchhoff's second rule supports the law of conservation of energy.